Hello, I'm Bram Desmet with Flanders Scientific, and in this tutorial we are going to review calibrating the FSI XM311K with Light Illusion's LightSpace CMS. Other XM series monitors can be calibrated in a similar fashion, but make sure to follow specific guides and information for the monitor you intend to calibrate, as some procedures or recommended practices may vary by model. To start, we're going to go to the color menu on the monitor to make sure our settings are set up appropriately for the calibration we intend to perform. First, we want to verify that the color system is set to LightSpace, as we'll be calibrating with LightSpace CMS. Next, we will set the range to match the range of our test pattern generator. In this case, we'll be calibrating with DaVinci Resolve as our test pattern generator, and we'll be calibrating in video range, so we will select video range on the monitor. Then from the gamut selection, we'll select the memory position we plan on saving LUTs to. In this case, we'll be calibrating for Rec 709, so we'll set the gamut option on the monitor to the BT709 position. We also want to ensure that the temperature and EOTF are left at default, and finally, luminance mode can be set to 100 for an SDR calibration at approximately 100 nits. If you desire a slightly brighter or dimmer peak luminance target, you can select Custom and then use the Luminance Custom slider to dial in a specific target luminance range. So next we'll open LightSpace CMS and connect to the monitor by selecting the File, Upload menu option. Then from the drop-down list we will select XM. In this dialog window we will type in the IP address of the monitor, which can be found on the Monitor System menu. So here if we take a look at the System menu on the monitor, we can see that the IP address is 10.1.10.24, so we'll type that in here, and then we want to ensure that null cube is checked, which in this case it automatically will be because we have no LUT active in the background in LightSpace. Then we'll select 1D plus 3D, and we'll select memory position BT709. Then we will press upload, and what this is doing is loading unity or null cubes to the front 1D and 3D LUT positions. We then want to make sure we do the same thing for the back 1D LUT portion because there are 3 calibration LUT positions per memory slot on the monitor: the front 1D, the 3D, and the back 1D. Now we will hit upload, and we can see that this LUT uploaded successfully as well. We now know that we have unity LUTs in all 3 LUT positions, so we are starting from a neutral, uncalibrated, and native wide gamut place on the monitor ahead of profiling the display. The next step is to connect to our test pattern generator. In this case, we'll be controlling Resolve as our test pattern generator from LightSpace. To give LightSpace control over Resolve, we will first select the Network Manager icon in LightSpace, then click Enable. Now we'll open Resolve and ensure that there is media on our timeline. If you do not have media on your timeline, Resolve will not allow you to connect to LightSpace. Now we will select the Color tab, and from the Workspace menu, select Monitor Calibration, then LightSpace. A dialog will open requesting an IP address. Type in the IP address from LightSpace noted earlier, and then press Connect. It is important not to press Return or close this dialog window, as that will terminate the connection and it will not work with LightSpace as a TPG. So make sure that you leave this dialog window open in Resolve. Now we return to LightSpace and click on the Calibration interface icon. For larger display profiles, we could also click on the Display Characterization icon, which allows for larger volumetric profiling, but because the XM311K is a very linear display and we are calibrating for a fairly simple Rec 709 target, a series of simple quick profiles from the calibration interface will work just fine. If opening the calibration interface for the first time, we may get a probe-specific pop-up dialog. In this case, we are connected with the CR100 and it is on COM12, so we will press OK. Now it's going to ask to point the probe at a bright patch on screen. This request is specific to the CR100. Depending on the probe you are using, you may get no prompt or a different prompt. As you can see, at the moment the screen is only showing black, so we will simply cancel this prompt for now. Then move over to the sliders here and move them to generate a bright patch. If we are successfully connected to Resolve, then the image on screen should update as we change the patch values. You'll notice that if I'm connected successfully to Resolve as my TPG, that the test patch shown on the monitor will mirror the test patch color shown here in LightSpace. Once I've done that, I can now go to Options here and I can ensure that the CR100 is using an XM311K specific matrix. Next, we're going to make sure our extra delay is set to about 1 second, just to play it safe and avoid any out-of-sync readings between TPG and probe reads, and then we're going to hit probe calibration. Now that we actually have a bright test patch on screen, we'll hit OK. This will take just a moment as it syncs to the display. Then once you get the frequency sync done dialog, you can hit OK, then press OK again, and we are now ready to profile. So at this point, we're going to select the profile option shown here and select the type of quick profile option we would like to use. We will be calibrating for the back 1D LUT position first to establish a neutral white point in EOTF, so in this case we're going to use the gray only large profile, which takes numerous readings along the grayscale axis for us providing ample data for a good white balance calibration of the display. It is important to note that if you plan on using the back 1D LUT position as part of a calibration process, that you always calibrate for that back 1D LUT position first. Now with gray only large selected, we can select Start, and we are going to give our profile an easy to find name. In this case, I'll call this 1-1, so it shows up near the top of our profiles list. And now we can start the profiling process. LightSpace will now automatically generate a series of RGB triplets which are communicated to Resolve and displayed on the screen. As the test patches advance, LightSpace will automatically take readings with the CR100 and log that data in this quick profile. So we'll give this a few moments to complete and then build our back 1D LUT. Now you don't have to build a back 1D LUT. The calibration could be performed using just a 3D LUT by itself, but generally speaking, the back 1D LUT is helpful and that provides a neutral white balance and EOTF starting point ahead of profiling for the 3D LUT, thereby limiting the 3D LUT's responsibility primarily to volumetric control of the display's color volume. So now that our profile is complete, we'll just take a look at this gamma chart real quick, and you can see all the grayscale readings that were taken of the display in its uncalibrated state as part of this quick profile. We can now exit the calibration interface, and our next step is to select the color space conversion icon. From the color space conversion window, in this source dialog, we are going to select the target color space we want to calibrate for. In this case, Rec 709. So we will select the Rec 709 option. Once selected, you can see that the XY chromaticity values for the primaries in white are automatically filled out appropriately, along with the default EOTF selection, in this case Gamma 2.4. Then for destination, the way I find it helpful to think about this is the location where your LUTs will live, in this case on the display, so we will select the display profile we just performed. That'll be in our drop-down list here, and we called that profile 1-1, so we'll look for that profile and select it. Then we will give our LUT a name, in this case back 1D Rec 709, and then we will press Create to generate the LUT. Once generated, I can go back to File, Upload. Again, we have the XM series listed, the IP address of the monitor, we have the back 1D LUT position selected, we have the 709 memory position active, so these settings are all correct. We want to make sure that the null cube option is now unchecked so that the LUT active in the background is uploaded to the display. Again, because we have just back 1D LUT selected, only the 1D LUT portion of this LUT will be uploaded to the monitor. Then we will hit upload and we'll see a prompt telling us the upload was successful. Now we can both check our back 1D LUT result and run the profile necessary for creating our 3D LUT by returning to the calibration interface. Select profile once again, and in this case we're just going to select gray only, which will give us primary readings and a short series of grayscale readings. Then when we press start, we're going to call this profile 1-1-2, and then we'll select OK. And again, this will take a number of readings and log that into a quick profile from which we can build our 3D lookup table. Now, as mentioned, you can do a larger display characterization to take a lot more volumetric readings, but because this is quite a linear display device and because we are calibrating for a fairly simple Rec 709 target, that is likely overkill. Doing a quick profile-based calibration like this is a good first step to see if a larger display characterization may actually be worth your time, and it is also a great way to ensure that all your equipment is hooked up correctly and performing as expected before starting in on a prolonged characterization. So now that this is complete, we can take a look at the gamma response, and we can see that our back 1D LUT has given us a pretty bang-on EOTF response. We can also look at the RGB balance, and again we see that the back 1D LUT has given us very solid white balance tracking. We can now hit close and return to the color space conversion window, and this time we're going to build the volumetric 3D lookup table that will take us from the monitor's native wide gamut down to the Rec. 709 target. So again, we're going to select the Rec. 709 option in the source dialog. In the destination dialog, we are going to select the profile we just performed, which we named 1-1-2. We're going to call this Rec. 709-3D, and then we're going to select Create New. That's now complete, and we can see that this conversion is 100% within target. We can actually take a look at the 3D lookup table now. And now we can select File, Upload. Again, we verify we have the correct device and IP address setting listed. And we're going to select the 1D plus 3D option. We're going to select Upload into the BT709 option. Now, it's important to note here, I could just select 3D only. We, of course, already have that back 1D active, and choosing 3D only will work just fine. But if I select 1D plus 3D, that 1D LUT component of the 3D LUT will be extracted and uploaded separately into the front 1D LUT position. The front 1D LUT position on the XM311K is a 4096 entry point 1D LUT, so this gives us more granularity than we would get with the 3D LUT alone. So we'll go ahead and do 1D plus 3D, press Upload, and we'll see that both LUTs are uploaded to the monitor successfully. We can now close this dialog and we can verify our results. So from the calibration interface, I'm going to select memory colors with secondaries as my verification, both because these are colors we care about, like earth tones and skin tones, and because it is a separate set of data readings than the ones used for calibration, so a more thorough way to verify our calibration rather than simply reading the same values as before. We're now going to press Start, give our validation profile a name, and then press OK. This will again generate a wide variety of test patches, and once complete, we'll review the results to see how good our calibration is on this display. So now our verification is complete. We can hit OK, and as we can see, our color gamut coverage is excellent. We can go to our gamma coverage, and that looks pretty spot on. RGB balance looks quite good as well. We can look at our delta for white balance. Everything is well below 1 across all delta E metrics, so that is great. And then the delta E distribution graph really tells us the complete story, and what we are looking for here is a very left-weighted graph. What this tells us is that the percentage of delta E values that are between 0 and, for example, 0.5, and we see that depending on the delta E metric used, that is anywhere from 60 to 95% of readings. Then not much of anything really over 1 or 1.5, so this is a very good calibration that was done very quickly. Again, we could do a much larger display characterization, and there's no real harm in that, but the significantly larger investment of time likely only gives us marginally, if at all, better results in this particular scenario. However, those larger display characterizations can certainly be much more useful when targeting more complex targets like PQ, but for this, hopefully the video is helpful in showing how you can do an easy Rec. 709 calibration on an XM311K. If you have any questions on calibrating this or other FSI monitors, please reach out to our support team at support@flandersscientific.com. Thank you.